When we talk about solving systems of two equations, we can look at using either substitution or elimination, two different methods for solving these systems. The two methods are interchangeable. It's a good idea to practice both methods, and we'll look at examples of both. But really, if it comes down to which method you may prefer to use, one can be more advantageous in a certain situation, but as long as we're dealing with two linear equations, again, they're more or less interchangeable. We'll start off by looking at solving systems using substitution. But before we dive into that, we want to take a look at what exactly it is we're finding when we solve a system like this. It can be helpful as we're solving systems to identify our two equations as equation 1 and equation 2, just to save some time in referencing which one we're talking about. And then what I already have graphed here is the equation x plus y equals 4. So that's our equation 1, and x minus y equals 2, our equation 2. When we talk about solving this system, what we're trying to find are the pair of values, or the pairs of values, x comma y, where those two lines intersect. In this case, I already have these two lines graphed, and we can see that they intersect at the point 3 comma 1. So we know what solution we should get in the end here. But again, it's just a good idea to keep that in mind. What we're solving with a system of equations is the point or points where our two lines intersect. In order to do this, if we're using substitution, we would want to start by solving equation 1 for y. We actually have a few different ways to start. We can actually choose to solve either equation for either variable, but this is just the way that I'm going to start this problem off. In this case, to solve equation 1 for y, we would just have to subtract x to the other side, giving us y equals 4 minus x. Then what we want to do is substitute that result into our second equation. So our second equation starts off with x minus, and then in place of y, we're going to substitute this expression that we came up with for y in that first equation. So we're going to substitute in 4 minus x is equal to 2. Once we make that substitution, we're just going to distribute through and work on solving this equation that's now in one variable. So this will become x minus 4. Since that negative will distribute through, this will become plus x is equal to 2. We can combine our like terms and add 4 to the other side to give us 2x equals 6, or x is equal to 3. Once we solve for our first variable, then we can substitute into either of the original two equations. What I'm going to do is choose to substitute into the first equation because I already have that solved for y. So when I substitute x equals 3, my work for solving is already done, so that's just going to make my process a little bit easier. So I'm going to get y is equal to 4 minus 3, which is that value we came up with for x. So we're going to get y is equal to 1. So since we got x is 3 and y is 1, this gives us the solution 3 comma 1, which is what we were expecting since we already had that solution graphed. But just to verify and again reinforce what it is we're solving. In example 2, we still want to apply substitution. We'll start off by identifying each of these equations as 1 and 2. And what we'll do in this case is take equation 2 and solve for y. So this will become y equals 12 minus 5x. Again, we can choose to start off by solving either equation for either variable. In this case, this just seemed like the easiest choice to me. And then we'll substitute that into equation 1. So when we encounter that y, we'll drop in the 12 minus 5x that we know is equal to y. and then distribute through and solve for x. We know that we're on the right track with this substitution method because what we've ended up with here is an equation with just a single variable. Once we have an equation with just a single variable, that means we'll be able to solve. So distributing our 4 through will give us minus 48, and then minus 4 times negative 5 will give us plus 20x is equal to negative 4. So we'll get 22x, and then adding 48 to the other side will give us equal to 44, or x is equal to 2. We can then take that result and substitute back into equation 1 or 2. I'm going to choose to substitute into equation 2, which I've already solved for y. And then actually in place of x, what we'll do is drop in that value for 2 that we've found, which will tell us that y is going to be equal to 12 minus 10, or 2. So giving us the solution, which is an xy coordinate pair, 2, 2. Or again, meaning that those two lines intersect at the point 2, 2. In example 3, we have a slightly different system in the sense that this first equation, if we refer to that as equation 1, it's already only a single variable equation. It only has an x. So our easiest choice is going to be to take that equation and solve for x. Dividing both sides by 5 would give us x is equal to 6. So then what we'll do is take equation 2 and drop in that value we just found. In place of x, we'll plug in 6 plus 3y is going to be equal to 0, which will give us 3y is equal to negative 6, or y is equal to negative 2. So that ends up giving us the solution 6, negative 2 as the point where those two lines intersect.